Hi,
Morning.
good morning.
Morning.
Morning, welcome back. We're starting Unit 11. We're going to start off with what should feel very much like an Algebra 1 baby review to you, which is we're going to be adding and subtracting polynomials.
Easy algebra.
I know. Do you remember what a polynomial is?
It's one with two thingies.
More than
Variables.
Terms. Terms, things with variables, so you're not wrong. So if I were to look at this thing, here's one polynomial. How many terms does it have? 4? How did you get that?
Because it has four. That's one that's a constant.
Yeah, one of them is a constant. There's no variable. And I have 4 things that are being separated by an addition or a subtraction. Those are terms. So there's one term, there's another term, there's another term, there's another term.
What are the ones that are called? The ones that like have like a variable and an exponent. Because I know the one that doesn't have anything is.
When it's just like this,
Yes.
you can call this a monomial, which basically means one term thing.
Oh, okay.
And it's a variable because there's a variable in there.
Oh, okay.
Great questions, thank you. I want to play with number 4 today. Now, as we're working on this, so just some preference on writing style. First off, some new vocabulary for you. As we're working with this, we want to keep track of like terms. Like terms have to have the same variables, so the same letters, and those variables have to have the same degree. That means the exponent. So the exponents, all of them, have to match in order for you to be able to add or subtract them together. Okay? Okay. So let's look first at this thing, and let's use some distribution to get rid of those parentheses. Is there anything outside the parentheses to distribute?
Nope.
No, which means I don't have to do anything. I can just get rid of the parentheses. I love when there's nothing to do. Okay, proofread my work. It's already happened where I wrote the wrong sign because I wasn't thinking. All right, I'm good? Fun. All right, let's look at the second polynomial. Is there anything outside that polynomial that I'm multiplying by? No, I only see a plus sign. So there again, there isn't anything to do. I'm just going to get rid of the parentheses and write everything as I see it. Done. Now I'm going to use what's called the commutative property. It's the ability for me to shuffle things around and to change the order of things without messing anything up. And I'm going to do that to get all of my like terms together in like next to each other to associate them to make it easier for me to see what I'm adding or subtracting. Okay?
I thought you were solving it. Oh.
We're not solving.
Oh, I see.
Solving, there would be some sort of equal sign or inequality sign, and then we would be solving. We're not doing any kind of solving. We're going to have a big, ugly mess when we're done. And that'll be our answer, and we're going to be okay with that. All right. First thing to do here when we're collecting our terms is to find the highest degree term that we can find. That means the thing with the biggest exponent.
X to X.
7 would be the highest degree. 8x to the 7th is the term that we're looking at. Yep, so I'm going to write that. I'm going to scratch that off. Is that the only degree 7 term that I see?
Yes, ma'am.
Awesome. What's the next highest degree that we see?
6.
The 6?
It's just one.
Here it is. Again, it's just 1. I'm going to go ahead and write that in my black ink just to say that it's static and I'm not going to make any changes.
Negative
All right.
2.
What is my next highest degree? With 5, and so I have one here. There's 2.
It's negative 2.
We have done this before. We've done this
It's negative 2.
in Algebra 2.
Well,
In regular algebra, right?
Yeah, in regular Algebra 1. We've been doing it when we do solving and things. So we're just going to kind of reinforce that.
Oh, you're moving them next to each other?
Yeah, right now we're just moving them so that they're together. If you can already think through the adding of the coefficients, go ahead. But I'm showing you where that's coming from. All right, next highest degree, the 3.
Miss,
One
the
here,
4x5
and
is
one
positive.
here. It's positive?
Yes.
Okay, I believe you. Here we go. We're on number 4, my dear. Plus 4x to the 3rd minus 3x to the 3rd. All right, next highest is the negative 6x. What's the degree on that term?
Wait, is it that a 1?
1, yes, because the exponent is a 1. Good job.
Oh, wait, never mind.
All right, and then what's the next highest degree?
2.
I loved how we had different answers. Okay, you said 2 because you were looking at this thing, and so you said what that was. And then the ladies had said 2, it said 0, because I asked what was the next degree. What was the
Oh.
next exponent on the variable?
Oh, 0.
0 because I don't have an exponent. I don't have a variable. Okay, I could, if I really wanted to, put a variable on there, and it would look something like this, confirming that I have an exponent of 0. What? When we raise something to the 0 power, what does it turn into? 1. So this is actually 1, so this says 2 times 1, which is
2.
2. But if you're talking about things in terms of its degree, in terms of the exponent on the variable, a constant is a degree 0. Because if I were to put a variable on it, that variable would have to have a power of 0. Otherwise, I'm suddenly changing the value of this constant, which I can't do because it's supposed to be constant and don't change. Okay? All right, I'm setting you up for calculus. You're welcome. Okay, going to start cleaning up and actually doing that combination now that everything is associated the way I wanted it to.
To the power of 5.
Negative 2x to the 5th,
Then 1x to the 3rd.
then positive 1x to the 3rd, but I'm not going to write the 1. I'm going to leave it as implied.
Oh, I put the 1.
You can put the 1. You don't have to put the 1. I'm choosing not to because I'm lazy and I don't want to write it.
Miss, do we have to like actually write it how you did it, like take away the parentheses and then do it like that?
I recommend that you take away the parentheses to see what you're looking at, and then somehow differentiate all the like terms just so you don't get lost because there's going to be a lot of stuff
I
happening.
just solved it.
Okay? If you're already fairly comfortable with going all the way through, that would be okay. But for those of you who this was challenging for you last year, the year before, whenever you did Algebra 1, this is what was happening. Okay? In case that teacher did the magic trick and never showed you how to, how to actually do it.
She just kept repeating.
They just kept
combined-
repeating and hope
combined
that
like
you
terms,
managed to
that's
do it. Yeah. This is what they were doing. All right, let's flip the page and let's look at number 15. That's it.
It's just like that.
It's just like that because we're not solving. So we don't need x equals number. We're just adding and subtracting. All right, number 15. Looking at the first polynomial. Anything to distribute? So do I need the parentheses? Okay, so I'm going to write it without the parentheses, and everyone's going to be happy. And there was much rejoicing. Yay. Next polynomial. Anything to distribute? The negative. I'm so glad you saw that. Okay, so I'm going to distribute the negative. Distribute that negative doesn't change the coefficient, the number in front of the variable. It only changes the sign. So that's why I'm writing it with just the signs in the different color, showing that I'm changing just the sign and I'm not actually changing the number of the coefficient. Whoops, sorry. Okay.
That's a plus, right?
It is in front of the 7. Yes, it's a plus. I started in the wrong color. All right, I'm going to play the game again. I'm going to look for the biggest degree, and I'm going to write all the things of that degree next to each other.
4.
4 is the biggest degree. There's everything with that biggest degree. I'm going to go ahead and write those up in
I have
front.
a question. So it goes in order or it goes from highest to lowest?
This is,
Not with the degree, but with the number in front of the x.
with the number in front of the x, it doesn't matter, it's only by degree.
Okay.
And honestly, you don't have to put it in any kind of particular order. I just highly recommend that you put it in order of biggest degree to smallest degree, because when we start getting into the factoring again, having them in order like that makes some of the factoring steps easier.
Oh, okay.
Okay? So this is just kind of, we're leading up to that. Fantastic question, thank you. Next degree? 3, and there's only one of those. Next degree?
2.
The 2, this one, and this one. Next degree? 1.
The 5
Next
is,
degree?
the 5 is positive.
0. The 5 is positive?
On the red.
No, it is
3.
not.
Oh, because you changed the sign on
So
there.
they change the sign. All right, now we're going to do that combining like terms. Now that we've associated all of the like terms together, we can combine them. I have negative 11 here and positive 11 here. How many do I have? 0. No changes to the third degree. Here's the second degree. Here's the first degree. And here's the 0 degree. Do I need to write 0x to the 4th?
No,
Why not?
because wait, actually you do. Because if you don't, it would be like 1x.
Okay. Do I need to write this term? And she said no. She said yes because
If you don't put it, it's gonna be 1.
if I don't put it there, I have to be a 1. Okay. So let's make up a number for x. Any number you want.
200.
200. Okay. If I take 200 and multiply it to itself 4 times, don't actually do that in your head. That's going to hurt. It's a big number, right? Now multiply that big number by 0. What do you get?
0.
0. So no matter what I stick in here for x, my result is a 0. So I can replace that entire thing with a 0. And now I have 0 minus and plus some other things. If I add or subtract to or from 0, does it change the thing? No, which means I don't need to write the 0.
Oh, I thought you meant like just take out 0 and leave the x.
Ah, great question. She thought take out the 0 and leave just the x to the 4th. You were correct then in saying no, you have to write that 0 there. Because if I just took away the 0 but left the x to the 4th, it would be as if I were saying that there was 1x to the 4th. I understand where you were coming from now. Thank you. Thinking was absolutely correct. Good. All right, that's it. That's as far as we can go. With these, you go as far as you can, and once you get to the point where you can no longer add or subtract or combine like terms or anything, then you stop and call it done.
Wait, so you don't combine, you don't like solve the whole thing?
Nope, there's no solving because there's no equal sign.
Oh, okay. Oh.
Yeah. That's very